Welcome to our Zaption for Lesson 2.4 on direct variation. We're going to be talking about the investigation today, so you can work on it a little bit for homework and come prepared to discuss it more in class. Just for some background, in Lesson 2.3 you worked with conversion factors to change one unit of measure to another. You also worked with rates such as miles per hour and saw that a rate has a 1 in the denominator. This makes rates convenient to calculate with. You'll see some patterns arise when you use rates to make tables or graphs, and so in this investigation, you're going to use algebra to understand these patterns better. You're going to need your investigation sheet that's titled Ship Canals, and you're also going to need a ruler. You'll note here at the top, you also need a graph and a table, which are included in the worksheet. So in this investigation, you'll use data about canals to describe a graph and write an equation that states the relationship between miles and kilometers. You will see several ways of finding the information that is missing from this table. So the table we're talking about is this one right here, and you'll notice that we're missing two different values. We're missing a length of the Suez Canal in Egypt, and we're missing a length of the Trollhättan Canal in Sweden. And we're missing one of the lengths in kilometers, and we're missing the other length in miles. The beginning of the investigation focuses on the graph. So I'm going to let you work through steps 1 through 4. You're going to begin with setting up your graph. So for example, scaling the axes of the graph, plotting the points for the first 8 coordinates, which you'll find here on the table, thinking about what pattern or shape you see in the graph, plotting a point at 0, 0, so 0 miles, 0 kilometers, and connecting that to the shape that you've noticed. And then step 4, finding those missing values based on the pattern that you've noticed in your graph. When you're ready, then go on to the next piece here, where you're going to see kind of a key to what you should have. So let's take a look at those first 4 steps and see how you're doing so far. So you'll see here that I've scaled the axes of the graph by approximately tens. I marked in every 50 just to make it a little bit easier to see, but each small box there is worth 10. And you'll see approximate points for those first 8 coordinates, including one that just goes a little bit off the graph. So step 2 asks about a pattern or shape that you see in the graph. And here I'm noticing that this seems to be making a straight line, approximately. It's not perfect, but it seems to be making kind of a straight line. And it's going up. So I might want to be making some observations about that on my answer. And then on step 3, I'm being asked to plot the point 0, 0. And in this case, I can see 0, 0 is at the origin, and it looks like this is connected to the line that I have found to kind of make sense of my pattern. So now I'm moving into step 4, and I'm finding the length of the Suez Canal. And the Suez Canal has a length in miles of 101. So I'm going to go ahead and go over to approximately 101. I'm going to go up, and I'm going to say that my point is approximately here. So I'm going to call that value perhaps around 160, maybe 161. I'm just going to give it an approximate sense of how I did that. And to show a point on here, right, I'm going to label that as well, so I know that that's the Suez Canal. And again, I can kind of show how I approximated that by just maybe having some little lines here, something showing about how I found a length in miles of 101, and I looked for where that intersected with my graph. Then when it comes to the canal in Sweden, I am going to work from the other side. So I know the length in kilometers is around 87. So I'm going to go 50, 60, 70, 80, 87 is kind of close to 90. And I'm going to go across here, and I'm going to go ahead and put a dot where I think that that approximate canal would be. So again, that's the Trollhättan Canal in Sweden. And I'm going to call that value around, say, 60, maybe a little bit less than that. So I'll put in some type of estimate. Maybe I'll put around like 58. Say it looks close to that. So again, you're going to come up with your estimates Ours may not match exactly, but they should be approximate. Now we're ready to go on to the next steps. Moving on to step 5, you're going to go ahead and fill in the table with the ratio of kilometers over miles using a fraction for the first 8 canals. So again, notice it's kilometers over miles. So in this case, for the Albert Canal, it's 120 over 80. And I'm going to just simplify that. It's okay to leave it as an improper fraction. I'm going to simplify it all the way down to 3 over 2 and leave it like that. And then I'm also going to write it as a decimal. And note it says to round to the nearest hundredth. In this case, 3 over 2 is just 1 5/10. So I'm just going to leave it with a tenths place, not add a 0 for the hundredths place. But again, you're going to go ahead and find those values for all 8 of those canals. And then in step 5, part 3, you're going to find the mean ratio of that last column. So add up all 8 of those decimal values and then divide by 8 to find the mean number of kilometers per mile. And then in step 6, you're going to go ahead and solve for the missing values for the Suez Canal and the Trollhätte Canal in Sweden by using the mean ratio that you have found previously. So when you find approximately how many kilometers are in 1 mile, you're going to go ahead and figure out, well, if there's 101 miles in the Suez Canal, approximately how many kilometers long would that be? And you go through the same process for the other canal to figure out the other missing value. At the end of this, you should be able to see a constant. So the number of kilometers should be the same for every mile, so the value you're finding is called the constant. And again, you should be able to figure out what the variation constant is for kilometers and miles. So again, how many kilometers are in 1 mile? So when you're ready to move on, go ahead and go to the next piece, and you can kind of go through your answers and make sure you're on the right track. So here you'll see a completed table with the fractions and the decimals, and you'll also see that mean value of 1 6/10. So that means that there's approximately 1 6/10 kilometers in 1 mile. And now we're going to use that to help us figure out the missing values. So 1 6/10 of a kilometer in 1 mile, that's going to be set up actually in both proportions. So I'm just going to do that now. And then for the Suez Canal, the length in miles is 101. So I'm going to match up 101 with miles and put X for kilometers. And on the other, for the Trollhätte, I'm going to put in 87 for the kilometers and have X for miles since I'm solving for miles. So now I'm going to be solving for my missing values. And you should be familiar with how to do that now that you've been solving proportions a little bit in class. So in this case, to undo dividing by 101, I'm going to multiply both sides by 101, and these will cancel out, leaving me with 101 times 1 6/10 divided by 1 will just be itself. So if I go ahead and solve for that, 101 times 1 6/10 would give me 161 6/10. So again, that's the number of kilometers for the Suez Canal. I can add that to my table as well. And then in my other proportion, you'll notice that I have the X value on the bottom. So I need to flip both sides of the proportion. So I'm now going to have 1 over 1.6 kilometers equals X over 87 kilometers. And now I can undo dividing by 87 by multiplying both sides by 87. And I have 87 divided by 1 6/10 to solve for X. And so 87 divided by 1 6/10 is going to give me 54 375 thousandths, or if you want to just round that to say 54 4/10, that would be fine too. And again, this is miles, and this is the number of miles for the canal in Sweden. So at this point, you've also found what we call this constant. And the variation constant for kilometers and miles should be then 1 6/10, or 1.6 kilometers to every 1 mile. Now we're moving on to step 7 and 8. In step 7, you're going to write an equation, thinking about how you can go from miles and kilometers between each other. So go ahead and write an equation to show how those are related using the variables x and y. And then with step 8, you're going to use the equation that you found previously to actually solve for those missing values for the Suez Canal and the Tralhady Canal. So try those and then come back here to see if you're on the right track. So going back to step 7, your equation should look like this. Y equals 1 6/10, or 1.6 for the constant rate, times x. So in this case, again, y stands for kilometers. 1.6 is that constant rate. So again, the number of kilometers per mile. And then x is representing our number of miles. So let's test it out and see if it works. So with the Suez Canal, we don't know the kilometers. So we're going to have y equals 1 6/10 for the constant rate times 101, which is the number of miles. And when we multiply that out, we get y equals 161 6/10 kilometers, which matches with what we found in our proportion earlier. And then for the other canal, the Tralhady Canal, we are going to actually work a little bit differently because now we know the kilometers. So 87 equals, and we're going to fill in again the constant rate, 1.6 times x. And this equation might be a little bit more challenging for you to solve, but if you know a little more about solving equations, just like we were talking about before, if you want to undo multiplying, you could divide. So you might have divided each side by 1 6/10, and in that case you would have x would equal 87 divided by 1 6/10, and we would have about 54 4/10 if we rounded it. And so again, 54 4/10 of a mile. And if you would like to, if you weren't sure, for example, about the dividing by 1.6 on each side, you could also use guess and check. You could multiply 1.6 times some different values and see when you get something close. So again, I'm going to fill that in here into my table. This should match with what you saw previously, again, from our proportions that we solved before, and it's relatively close to what we saw on the graph. So you want to think about how is this equation like using a rate, and that's something we'll explore a little bit more in class tomorrow. So let's move to the last piece. So at the end of this investigation, we're hoping you're starting to see that ratios, rates, and conversion factors are all closely related. And so, for example, in this investigation, you saw that when we changed the ratio 129 kilometers over 80 miles, it became a rate of approximately 1 6/10 kilometers per mile. We can see that that rate is a conversion factor between kilometers and miles. Even though we may change the numbers in the ratio, the resulting rate should remain the same or constant. So like you saw when you compared all 8 of the canals, the ratio was still the same. Again, what we call this is a directly proportional relationship. We say that kilometers and miles are directly proportional to each other because there's always the same number of kilometers in every mile. And when two quantities vary this way, we also call this relationship direct variation. And a little bit more about direct variation, you're basically looking for an equation in the form y equals kx. That's your clue that this is a direct variation situation. And the quantities with x and y are what we call directly proportional, and they're related by the constant of k, which we call the constant of variation. So like you saw before with the equation y equals 1.6 times x, y was our number of kilometers, 1.6 was our rate, and x is our miles. Again, we would say that y and x are directly proportional to each other, that they are in a direct variation relationship, and that they are related by this special constant. In this case, it's 1.6, representing the 1.6 kilometers per mile. So tomorrow in class, we'll continue to explore direct variation. Hopefully you feel good about this investigation, and you can think about any questions you might want to ask for tomorrow. See you then.